Okay, we're going to talk about percent of change in section 3.7. So the first thing we want to look at is that percent of change is an increase or decrease expressed as a percent. So if I'm just talking about an amount, how much did something go up or how much did something go down, that's just the amount of change. But if I discuss that change as a percent, then we're talking about percent of change. So the percent of increase is used when the new number is greater. We have an increase. And obviously, percent of decrease is used when the new number is less than the original. We have decreased something. Okay, so finding percent of change. Let's do a couple examples. Here's the first one. If the original is 25 and the new number is 28, the first thing I want to find is what is the amount of change, not the percent of change, but just the amount of change. So by taking 28 minus 25, I find that we have increased by 3. So this is the amount of change, increased by 3. The question though is what percent of the original, because I want to know how much the original has changed, is 3. Well, that's talking about 3 out of 25 is the same as x out of 100. We all know that percent is out of 100. So using what we did in our last section and rewriting this as a cross product, 3 times 100 equals 25x. So 300 equals 25x, and if I divide by 300, I get 12. This is the percent. 12 out of 100 is the same as an increase of 3 out of 25. So the percent of change is a 12%, and we want to note that this is an increase. Okay, so here's one where the new value has a decrease. So first of all, find the amount of change. Pause the video. Okay, the amount of change is 30 minus 12, which is 18. Now I want to put 18 in terms of a percent. What percent of the original is 18? So set up a ratio for me. Pause. So 18 out of 30 is x out of 100. So I'm looking for what percent, what number out of 100 is the same as an 18 increase out of the original 30. So using cross product, 1800 18,000 times 100 equals 30x. Divide both sides by 30, and I get x equals 60, or 60% decrease. Okay, and keep in mind that when you do this, you should be able to look back and see if this is reasonable. 12% is a fairly small amount of increase. A 10% increase, 10% of 25 is 2.5. We just moved the decimal over 1 for 10. And we had an increase of 3, so it should be just a little bit more than 10%. A decrease of 60%, that's more than half. Has this decreased by more than half? Yeah, it has. So that seems like a reasonable answer. Okay. The next thing we want to do is just write down a couple of quick steps so you have them in your notes. So the first thing you're going to do is to find the amount, the actual amount of change using subtraction. And then the amount of change divided by the original value to find the percent of change. And remember, it's the amount of change over the original is set equal to the percent of change, and that's my unknown, divided by 100. Okay, so that's what we're going to do for our steps here, and that's how we will find it. And then we're going to use this for some other problems as well. So let's do some others that aren't quite as straightforward. The field used by the NFL, National Football League, is 120 yards long. The length of the field used by the CFL, Canadian Football League, is 25% longer than the one used by the NFL. So it's going to be a percent of increase with the NFL's length being my original, and the CFL's length, which I don't know what it is, so I'm going to call it L, being the new value. And this time I know the percent. The percent of increase is 25, but I don't know the new number. I know the original, I don't know the new, I know the percent. So let's take our plug-in pieces from the last one, where we had the amount of change divided by the original equals the percent of change divided by 100. So I know the original, 120. I know the percent of change. What I don't know is the change between the NFL and the CFL. And remember, we found that by subtracting. I know that the CFL is longer, so if I do L minus 120, that would be the amount of change. And that's what I don't know yet. So, using cross product, 120 times 25 equals 100 times L minus 120. Using a calculator for this, we're going to get 3,000 equals 100L minus 12,000. So if I add 12,000 to both sides, I get 15,000 equals 100L, and divide by 100, L equals 150. So the length of the CFL field is 150 yards. And does it make sense that that's a 25% increase over the 120 yards? Well, it's certainly an increase. What's a quick way to find 25%? 25% is 1/4, right? So if I take 1/4 of the 120 yards, I'm just checking my work using a different method, that would be 30 yards. And is the CFL field 30 yards longer than the NFL field? Yes. So it's increased by 1/4. Okay, a concert ticket costs $45. If sales tax is 6.25%, what's the total price of the ticket? So again, the total price of the ticket is going to be the original plus the sales tax. So we're going to look at this one. We're going to take our original, $45, not percent, plus the sales tax. And the sales tax is 45 times 6.25. And that's going to be the new, or the total price of the ticket after sales tax, right? Total amount. So 45 plus, this was a percent. How do I multiply a percent? Do you remember having to change that to 0.0625? And then using your calculator, we get 2.8125. But since we're talking about money, we need to round it off to the nearest penny. So we need to round it off to this decimal place, and the 2 will not increase it. You know that if this number is more than 5, you have to raise it up 1. And so my final answer is $47.81. Okay, let's look at one more. A sweater's on sale, so now I'm going to reduce it by 35%. So $38 minus the reduction, which is 38 times 0.35. So the original minus the reduction, which in this case, if you get your calculator out, is $13.30. And if I subtract, I get $24.70. So that's my sale price. Okay, so we've done a couple examples. We've looked at percent. Again, if you have questions on this, please don't hesitate to ask, and we'll go over this in class together.